Hey guys, let's look at these questions for the differential equations, finding the particular solutions in questions 1 to 4. So our first step in all of these is going to be to separate those variables. So when we separate these variables, this y that's in the denominator, we're going to move it to the left side, and on the left side we're going to have y dy is equal to, on the right side, x squared dx. Second step is we'll take the antiderivative of both sides. Y squared over 2 is equal to x cubed over 3 plus c. Now we're going to use that initial condition that when x is equal to 3, y is equal to negative 5. So we're going to plug in negative 5 for y and positive 3 for x. Negative 5 squared is 25. 3 cubed is 27 plus some unknown constant c. So now we can subtract 27 thirds from both sides and solve for c. So when we subtract 27 thirds, we have 25 over 2 minus 27 over 3 is equal to c. When we add or subtract fractions, we got to get a common denominator. So multiply u by 3/3 and u by 2/2. We get 75 minus 54 over 6. That's a terrible 6 is equal to c. 75 minus 54, which is equal to 21/6 or 7/3. So now we're going to come back up here and we're going to plug in 7/3 to both sides. So now we're going to make u 7/3, and we have y squared over 2 is equal to x cubed plus 7 over 3, because they had a common denominator. Multiply both sides by 2. Y squared is equal to 2x cubed plus 14 over 3. Take the square root of both sides. Y is equal to the square root of 2x cubed plus 14 over 3. Now because our initial condition was negative, when we take that square root, it's going to be negative. Now when we separate our variables here, when we move this to the left side, we're going to get 1 over y dy is equal to 6x squared dx. Take the antiderivative of both sides. The antiderivative of 1 over y is the natural log of y. When we add 1 to this, we get 6x cubed divided by 3. So we get 2x cubed plus some constant c. In order to get y by itself, we're going to say y is equal to e to the 2x cubed. And rather than writing that plus c in the exponent, we're going to multiply it by k, because e to the c is just some constant. Now we're going to use that initial condition. So plug in 0 for x. 4 is equal to k times e to the 0. So k is equal to 4. Y is equal to 4 e to the 2x cubed. Separating these variables, we're going to bring y squared to the left side, and so it's 1 over y squared dy is equal to negative x dx. Taking the antiderivative of the left side and the right side, it's tempting to say it's the natural log of y squared, but our exponent in the denominator is not 1, so you have to treat this like it's y to the negative 2, which the antiderivative of that is negative 1 over y is equal to negative x squared over 2 plus some constant c. Let's use that initial condition. Negative 1/4 is equal to 0 plus c. So we can come back up here, knowing that c is equal to negative 1/4. Negative 1 over y is equal to negative x squared over 2 minus a fourth. On the right side, we can get a common denominator. by multiplying by 2 over 2. So negative 1 over y is equal to negative 2x squared minus 1 all over 4. We can change that negative sign so to have 1 over y, but on the right side it's 2x squared plus 1 over 4. And now we want to flip this over, so we just have to flip this over. Y is equal to 4 over 2x squared plus 1. First step, always separate those variables. 1 over y dy is equal to 4x cubed dx. Take the antiderivative of both sides. The antiderivative of 1 over y is the natural log of y. Add 1, so 4x squared over 4 is just x to the 4th plus c. We can get y by itself by saying e to the x to the 4th, and again, rather than writing plus c in that exponent, k. Initial condition is that when x is equal to 0, y is equal to 7. So e to the 0 is just 1, so 7 is equal to k. Y is equal to 7 times e to the times y is equal to 7 times e to the x to the 4th. That was a really big multiple there. Okay, guys, that was the first 4 questions. I'll make a video of the next 4. Something to particularly pay attention to in question 5, which I'll get to when we do that video. Guys, I hope you're having a great weekend, and I'll see you tomorrow.